Imagine this. You've heard of massive AI models that need expensive GPUs and tons of power, but what if you could run cutting-edge AI on your laptop without killing your battery? Most people think small AI models are weak, slow, and inaccurate, just watered-down versions of the big players. But Microsoft's new BitNet B 1.58 breaks all the rules. It's tiny, yet incredibly smart, fast, and energy efficient, and it doesn't need fancy hardware to compete with the giants. In this video, I'll show you how BitNet works, why ternary weights make it a game changer, and how this tiny AI might reshape everything from mobile apps to offline assistants. Backed by Microsoft's rigorous benchmarks and real-world testing, BitNet is already proving itself smarter and faster than most people ever expected, and I'll break it all down for you right now. You're probably thinking, we've already heard about tiny models before. Aren't they usually watered-down versions that compromise accuracy just to save space? Not this time. BitNet is different. It's not a stripped-down version of something bigger. It was designed from the ground up to be lean, efficient, and surprisingly powerful. And the secret? It all comes down to three simple numbers: -1, 0, and +1. The power of ternary, why simplicity wins. Yes, really. Instead of the complex floating point weights used in traditional models, BitNet runs entirely on ternary weights. That means every piece of knowledge inside this AI is stored using only 3 possible values. This tiny range dramatically reduces the memory it needs to function. On average, each weight in BitNet stores just 1.58 bits of information, hence the name. But here's the crazy part. Even with this brutally simple system, BitNet keeps up with the big players. But how is that even possible? Aren't smaller models supposed to be dumber? Not when they're trained smart. Unlike many low-bit models that start big and are later compressed, BitNet was built small from the very beginning. Microsoft trained it directly using ternary weights, allowing it to learn and adapt within its strict limitations. This means there's no lost accuracy from post-training compression. It knows exactly how to work with what it has. Small but mighty, how BitNet competes with the giants. And the results are impressive. BitNet boasts 2 billion parameters and has been trained on a jaw-dropping 4 trillion tokens. That's the kind of data scale you'd expect from massive cloud models running on expensive server farms. Yet BitNet manages to hold its own without demanding that kind of infrastructure. In benchmark tests, it scored just 1 point below some of the top full-precision models in its class. That's barely noticeable for everyday use, but where it really shines is efficiency. Let's talk numbers. A typical 2 billion parameter model in full precision consumes about 2 to 5 gigabytes of memory. BitNet, just 0.4 gigabytes. That's small enough to fit comfortably in the cache of most modern CPUs. What does that mean for performance? In testing, BitNet running on an Apple M2 chip produced 5 to 7 tokens per second, roughly the pace at which a person reads a paperback novel. And it does this while drawing up to 96% less power compared to its floating point competitors. That's like idling a Prius instead of revving a muscle car. In a world increasingly concerned with energy consumption and environmental impact, BitNet's low power draw isn't just a neat feature, it's a potential game changer. Proving itself how BitNet dominates the benchmarks. Still, speed and efficiency are pointless if the model produces garbage results. That's why Microsoft subjected BitNet to a gauntlet of tough benchmarks. Across 17 different tests, BitNet proved it can keep up and sometimes even outperform its float-based peers, especially in logical reasoning, where it beat many competitors in tasks like Arc Challenge and Winnow Grande, 2 notoriously difficult benchmarks. When it comes to math, BitNet flexes even harder. On GSM 8K, a test designed to measure mathematical reasoning, it scored 58.38%, higher than other models in its weight class, even those running on more bits and more watts. This isn't just about being small and cheap. BitNet is smart too, but perhaps the most telling comparison comes against models that tried to cut corners after the fact. Take Qwen 2.5 1.5b for example. When compressed down to 4 bits using post-training quantization tricks, its accuracy dropped significantly. BitNet, on the other hand, stayed rock solid. The lesson here? Being born efficient beats being squeezed down later. Inside the brain, the genius behind BitNet's design. So what's going on inside this tiny yet mighty model? To understand that, let's strip away the jargon. Picture a traditional AI model as a massive warehouse. Every shelf is lined with huge, heavy jars filled with precise numbers. Whenever the model needs to answer a question, it has to dig through these shelves and haul the jars around. That takes time and energy. BitNet simplifies the entire process. Instead of jars, it uses poker chips. Red chips mean -1, white chips mean 0, blue chips mean +1. That's it. The warehouse shrinks dramatically, and moving these chips around is lightning fast. A special worker called the ABS mean quantizer decides which chip goes where live as the model operates. Meanwhile, communication inside the warehouse is streamlined, using simple Lego-like bricks instead of complex data formats. This keeps the pathways clear and speeds up processing. Of course, simplifying things does introduce challenges. Chips and bricks can make the structure a little shaky. That's why BitNet includes stabilizers. The team replaced the usual activation function with a simpler squared ReLU, which handles rough edges better. They also borrowed Llama 3's tokenizer to avoid reinventing the wheel when it comes to understanding language. But training such a model isn't easy. Microsoft designed a three-stage process that mimics how a human learns. First, they exposed BitNet to massive amounts of data at high speed, the equivalent of skimming every book in a giant library. Next came the cooldown phase, slowing things down so the model could absorb details more carefully. Finally, they fine-tuned it with practice exams, teaching it how to respond accurately and conversationally. And it didn't stop there. The researchers even showed BitNet pairs of answers and gently nudged it toward choosing the better response. This step, called direct preference optimization, helped refine its output without erasing the knowledge it had already gained. At no point did BitNet switch back to traditional heavyweight methods. It stayed lean and mean from start to finish, and that consistency shows in its performance. Real-world applications, where BitNet wins. Now, let's get to the part that really matters. What can BitNet actually do in the real world? At first glance, you might assume a model this small would only be good for basic tasks or simple chatbots. But that's not the case. BitNet's impressive benchmark performance shows it's capable of handling far more complex jobs. Logical reasoning, math problems, and general knowledge tasks all fall comfortably within its reach. One of the biggest benefits of BitNet is its ability to run directly on CPUs. In a landscape dominated by massive models requiring expensive GPUs or even entire server racks, BitNet feels refreshingly accessible. On a modern laptop or desktop, even without a powerful graphics card, BitNet can generate text at human reading speeds, all while drawing minimal power. This makes it perfect for use in portable and offline environments. Think about smart keyboards that suggest text in real time without needing to connect to the cloud, or AI assistants that can run directly on your phone or tablet without draining your battery. Even businesses could benefit using BitNet to power chatbots, email responders, and document summarizers without paying for costly cloud computing. But it doesn't stop there. BitNet also opens doors for regions with limited internet access or for privacy-conscious users. When AI can run locally without sharing data with external servers, users regain control over their information. In a world increasingly focused on digital privacy, that's a huge selling point. And let's not forget edge devices. From smart appliances to wearable tech, BitNet's low memory footprint and power efficiency make it ideal for embedding intelligence in products that were previously too resource constrained to handle AI models. BitNet isn't just about performance, it's about bringing AI everywhere. The road ahead, Microsoft's big plans for BitNet. While BitNet B 1.58 is already impressive, Microsoft has made it clear that this is just the beginning. The research team is already planning the next steps, and they aren't thinking small. The paper outlining BitNet's capabilities reads more like a roadmap than a final product. First on the list is scale. The team wants to explore how well this ternary approach holds up at even larger sizes, specifically at 7 billion and 13 billion parameters. If the same efficiency and performance gains carry over, it could reshape the landscape for mid-size models entirely. Then comes hardware. Right now, BitNet runs efficiently on CPUs thanks to clever software, but it still has to pretend that its ternary values are standard integers when interfacing with GPUs. Microsoft researchers are openly calling for new, specialized hardware accelerators designed specifically for low-bit calculations. If manufacturers take that challenge seriously, we could see BitNet and models like it running even faster and more efficiently in the future. The roadmap doesn't stop at raw size and speed. Microsoft also acknowledges the current version's limitations. For example, the model's context window is still relatively short, limited to around 4,000 tokens. While that's enough for many tasks, it's not yet ideal for handling very long documents or complex conversations. Expanding this capability will be key for making BitNet even more versatile. There's also a strong desire to make BitNet multilingual. Right now, it's heavily trained in English, but global applicability demands more. Expanding to handle multiple languages will take time and effort, but it's a natural and necessary step if Microsoft wants BitNet to become truly universal. Finally, there's multimodal AI. While BitNet excels in text, the future of artificial intelligence is increasingly about blending text, images, and even video. The idea of adding vision capabilities to such a low-bit, efficient model is ambitious, but it's also on the research team's radar. In short, BitNet B 1.58 is not the final word. It's the start of something much bigger. The tiny AI that could change everything. So, what does all this mean? In simple terms, BitNet B 1.58 is rewriting the rules of what AI can be. For years, the trend has been bigger and more power-hungry models that require enormous resources to function. But BitNet flips that idea on its head. It proves that with the right design, small and efficient models can still deliver top-tier performance. And it does so while saving energy, running on everyday hardware, and offering the kind of accessibility that only local AI can provide. The possibilities are huge. From smarter mobile apps to AI-enhanced wearables, from offline assistants to embedded AI in everyday appliances, BitNet opens doors we didn't even realize were locked. And while today's version is already impressive, the future versions promise even more power and flexibility. Microsoft's journey with BitNet is just beginning. As they explore larger models, better hardware integration, longer context windows, and multilingual support, BitNet could evolve from an impressive research project into a cornerstone of AI at the edge. For developers, creators, and users alike, this is a sign that the next era of AI won't just be about massive data centers and sky-high compute bills. It will be about putting powerful, capable AI directly into the hands of everyday people. In the end, BitNet B 1.58 reminds us of an important lesson. Sometimes less really is more. And in a world where efficiency matters more than ever, that's a very big deal. If you found this fascinating, don't forget to hit that like button and subscribe for more deep dives into the latest AI breakthroughs. The future is coming fast, and BitNet might just be leading the way. So take a deep breath, check out the links in the description, and see you next time.